Hi there. This, I'm going to fess up, is now round 4 of me trying to get this video started. We've had alarms, we've had people come visit, all sorts of things. But it's okay because I have faith. This is the one. Anyway, this is SG1, and we're looking at sinusoidal functions. And these are functions that are based on a sine graph. Yeah, the one from trig, like as in the SOHCAHTOA, sine is opposite over hypotenuse, but we take it farther. So imagine you've got your triangle and you keep moving it and make, but then we're going to do a triangle that goes like this and all the way around and then some. Very cool stuff. So sinusoidal graphs are studied because they're really good at showing periodic and repetitive motion. So imagine exams are done, you're out at the lake, maybe you're sitting on the dock or on your boat or something like that, and you're fishing, and you've got like one of those little bobber doodads, and it's a little bit wavy. And if you were watching it, it would go up and down like that. Now, if we could trace its path as it's going up and down over time, you'd find it kind of made this wave thing. And that's what sine graphs are spectacular at doing. I'm not spectacular at explaining this, so we're going to try this. I've got a video and we're going to watch it. So give me a chance. I've got to do some magic here. It's probably been about 6 months since I've done videos, so please be patient with me. Okay, here we go.
Cosine functions. And to start with, I'm on a unit circle. That means the radius is 1. And if I draw a little segment straight down that forms a right triangle, then this vertical distance is y. This horizontal distance is x. So from the origin, I go out x, I go up y, and I hit the point xy. Now in a right triangle, the sine of an angle theta, which is this angle right here, is equal to the opposite side over the hypotenuse, which on our unit circle is y over 1. So the sine of theta is the y coordinate of this point on the circle. Let's go over to Geometry Sketchpad. And what I've done is I have linked this point on the unit circle to this point F right here. And so as it goes up and down, F traces out the y value of E. And along the x-axis, I'm going from 0 to 2 pi. So I'm going to bring point D over to the origin. I'm going to put E at 0 radians. I'm going to erase the traces. And we're going to animate point E and D. And as that happens, point F is tracing out the y values of point E, which correspond to sine values, as it moves along the x-axis linked up to point D. And that is a sine curve. At pi over 2, it hits a maximum. At pi, it's 0. At 3 pi over 2, it hits a minimum. And at 2 pi, it's back to 0. Okay, so let's go back and let's look at what cosine would be.
Okay, we don't need to. We just need to worry about sine. So I thought that was really cool. I'm just going to bring us back a little bit. That'll do. So he talked in terms of radians, which is fine. We'll still talk in terms of 360 degrees. So for, whoops, I'm just going to let that run till it gets to the end, back up to where B is.
And that,
boom, close enough. So you can see your maximum, if we work this out, this would be 90 degrees, and then 180, 270, and 360. So the magic is every quarter something happens. And you can see as this went around, this value kept going up. And then once it got to the top, it started to go down, which is this part. Went down, 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 till it got there, which is corresponding there. And it, excuse me, came back up. I think that's really cool how we can translate going around a circle into a cool curve. Okay, that's enough of that. I'm gonna go back to my camera. Okay, so we watched the video. Didn't have to watch all 6 minutes. We got the good stuff. Before, oh, a little chit chat. So I'm imagining that some of you, believe it or not, may end up taking calculus or pre-calculus. If you do, then you need to know about something called radians. So in the video, he was measuring the distance around the circle in terms of radians instead of degrees. That's cool. If you had to write a departmental exam, we'd have to worry about that, but we're not, because I write your exam. So it's no big deal. Radians, like it says here, it's just a different way to measure angles. Off the top of my head, I don't remember why radians is more important, but it is. So a circle is 360 degrees or 2 pi radians. So it'd be just like 2 pi. So the radian part is the same as the degrees. But I'm going to stop talking about that because we don't have to use them. The only thing, like I said here, is you might see them across the bottom on a graph. I've changed all your stuff so that it's in degrees. And if you take calculus, good, more power to you. Let's talk about periodic functions, ones that repeat themselves, just like, I feel like doing this. Let's see what we can do. Wait a minute, can I get it? Oh, that was really bad. There it is. Okay, close enough. Periodic table. I just let you, I should do that in the middle of the math thing. Back to math. Right, periodic functions, things that repeat. That's called the periodic table because the elements have characteristics which repeat as time goes on. Okay, math-wise, back to math. All right, so first of all, a periodic function is a function whose graph repeats itself at regular intervals or cycles. And yeah, it looks like a wave. You should have this. It should be colored. You know, the one thing that you could do, and what I try and do all the time, it just makes my life simpler, is on pretty much any graph I have to analyze in this chapter, I highlight the axes. And it takes, you know, not very long. But for example, on this one, if I'm not 100% paying attention, I might think this is where the x-axis is. I don't know why. Just because it looks weird. My brain wants the x-axis to be right in the middle. Okay, so if you're not sure, it's one where the numbers are. So here we've got it repeating. It's going up and down, up and down, up and down. This one does the same thing, way, way more gentle. Oh, wait a minute, what's the difference between the graphs? Well, what do you think? This one and this one repeat more often. So I should have done a better job and made these numbers exactly the same, but I didn't. It's the first time I'm doing this video. Wow, never mind, it's all good. So I guess I could say how fast the graphs are cycling, if that makes more sense. Because it goes from the top to the bottom. This one looks like it's a little faster, almost the same. But this one, right, if we start here, It's all the way out there, and it barely gets one done in that area. So that's one thing that's different. What's another thing? I feel a little bit like I'm Dora the Explorer. Sorry, Dora the Explorer, and I'm expecting you to be yelling at me. How about how high it is? Because if we look at this one, it looks like it goes up to 5. Well, I don't know how far that goes, but if that's 10, that's probably about 2. So high and low they are. Can you find a third thing? Because that was the one who was, it's a little tricky on my part. If you look at this one, where the x-axis starts, it goes up. This one is going up, but this one goes down. So direction when crosses x-axis. I guess we could also add like what number it's at when it crosses the x-axis, because this one, direction, we'll put location too. Location also, right? So this one here, it looks like it crosses the x-axis is this one. It looks like it crosses exactly at 0. This one, maybe at 2. I don't know how well you can see the background grid in there. This one, I don't know, maybe at 1. I'm not really sure. Okay, so, but they're all periodic functions. They're all wave functions. That's what you need to get out of this. Okay, ta-da, end of page 1. But there's 2 pages for this video. All right. So by the end, I guess I should tell you what we're going to be able to do. By the end, we're going to have a really scary looking, hold on. Equation. So say like y is equal to -6 sine 3x minus 45 plus 2. And you're going to be able to graph it. Okay. And I will also be giving you graphs that you need to analyze. But we're going to take it step by step. And then at the end, we're going to put it all together. And I think it's really cool that you'll be able to do all of this. So we need some more vocabulary. 1, periodic function. Already talked about that. 2, we're going to look at the different types of vertical measures. So these next 4 are up and down measures. And we do 1 sideways measure. But we're going to do up and down measures. All right. Maximum. Y'all know what it means. It's like, how high does the graph go? The only thing that's fussy is I want it as a teeny tiny equation. So if we look, here's my maximum. And it's going to be y is equal to 2. So all of these are going to be y, oops, sorry, the first 3 are going to be y equals something, just like I said there. Ta-da! There's my maximum. Hey, you can pause the video because I have faith that you can figure this out. Okay, pause it, please. All right, let's look at these ones. It doesn't matter which one I pick because they're all going to be the same. So y is equal to 3. And down here on this one, I don't have to color both of them either. Y is equal to 1. I could have made it and taken the whole graph and gone below the x-axis. The maximum could be negative. Doesn't matter at all. Okay, happy? Excellent. Minimum. Okay, really? Yeah, it's that easy. Oh, by the way, if you want to get all wavy with me, the top of a wave is also called the trough, the crest, but maximum is fine. Okay, so minimum is lowest point on the graph. It's the bottom of each wave, which is also called the trough. I like pink. Did I not just say in the last video or at the beginning of this video? Trace the X and Y axis. There. Boom. I also like my highlighters. $1.25 for 4 or 5 in the dollar store. It's a great investment. Here's a minimum. I'm just not going to mark all of them. One is good. There we go. I need y is equal to -2. Okay. Pause the video. Or just do it while I sit here and talk. I can't think of anything to say. All right. Y is equal to 1. And if we look at the bottom one, y is equal to -3. Cool? Cool. This is not hard. All right. Oh, where are we? Midline. I bet you could have guessed what it means if you have the maximum and the minimum. Now you've got the midline, which is the middle. All right. And again, we're having y is equal to some number. So if I look at this one, we need to find the middle. It's like right here. This is my midline. Excuse me. Y is equal to 0. So in this graph, it also happens to be my x-axis. That's fine. It happens. Okay. If I'm a little paranoid, what you can do is count. If you're not sure, this is my middle. It's 1, 2 to the max, 1, 2 to the minimum. Yeah, that would be the middle. Same distance up and down. There we go. All right, here we go. This looks like the midline. Here we go. So this is y is equal to 2. And it's always y because we're measuring it on the y-axis. When we start to graph these, the first thing we're going to do is draw our middle. And then we're going to say, well, we'll go same amount up, same amount down. There we go. And here we go, middle again. Y is equal to -1. Okay, so you can actually use a formula to find the midline. Let's do this one. So my midline is going to be my maximum, which is 3, plus my minimum, which is 1, over 2. It's going to give me 4 over 2, which is 2. It's there, you can use it. If you have a graph, I'm just going to look at it and count my boxes. But as I said down here, if I'm trying to explain it or something is weird about my graph and things just, I can't figure it out, it will work for you. Because finding the top and the bottom are pretty simple. So you just add them together, divide them. Let's try this one. Of course, if I was doing this, I would write up my equation, but I'm just squishing it on here. So 1 plus -3. It's always over 2. And that's going to give me -2 over 2, which gives me -1. And that's exactly what we had figured out. Boop. Okay, so those are the 3 that are y equals. You're literally just plotting them on there. The last one is the amplitude. And the amplitude is the distance from the midline to either the maximum or the minimum. Hold on. More highlighter colors. Let's go back to the top one. So we already talked about this. If I start at my maximum, and I go down to my midline, that's 2. If I start at my minimum and I go up, it's 2. Amplitude is always a positive number. For the record, any of these could be on, like, it could go up 2.5, or my middle could be at 1.5 or something like that. But we're just learning, so I keep it real simple. All right, so here's my middle. I'm going to go up. That's 1. And down, that's 1. So I guess I could make a graph that this was maybe like 10, 20, and 30. In which case, just pay attention to these. But 95% of the stuff we're going to do, those are all just going to be going up by 1. So it's simple. All right, I'm going to stop. You get to do the last one. Are you liking this section? You should be, because look, this is easy. From my middle to my top is 2. Middle to my bottom is 2. I guess theoretically, you don't have to count both of them, but you know, for the amount of work it is. Amplitude is equal to 2. And I'm going to say it again. Amplitude is always just a number. It's not y equals. And it's always, 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 always positive. It doesn't matter how your graph goes. It's just positive and be done with it. Here too, there is a formula, which again, I never use, but it's there. It's there if I'm having a bad day or honestly trying to show off, you know, in case Jody walked in and I wanted to look really cool. Let's try this one. Amplitude is my maximum, which is 1. Subtract -3 all over 2. A double minus makes it a positive, so that's going to be 1 plus 3 is 4 over 2. And that's going to be 2, which is what it was. I think the reason I don't use them is because those 2 formulas, for me, are too similar. In the old days, when I first started teaching this, we didn't have cheat sheets. So trying to remember which one was the plus and which one was the negative, it wasn't worth it. Anyway, so ta-da! There's the end of the first video. I've only got 8 more to shoot today. Bye!